Wanted to do a more fun video today, so we're going to do kind of a Friday night coding session, problem-solving mindset type video. How do we read and deconstruct the JOT token, and then how do we populate HttpContext.User and Thread.CurrentPrincple and make sure that that's available as part of this stateless, sessionless ASP.NET Core backend? So in front of me, I have a web application for a game that I play. We have an alliance in the game. We have a team of about 100 different people, and you fight other teams. And so we're building a website to help people manage these teams and their rosters and track scores and do statistics and all this other type of stuff. So anyway, though, we have effectively a login integrated with Google Login. So we go out, and I'll go ahead and refresh the browser, and we can see it does the automatic sign-in using, I believe this is the one-touch experience. And when that completes, we get back a JSON Web Token from that experience. We store that in the app, and then we send that to our ASP.NET Core backend. I'm going to go ahead and set a breakpoint on this payload here. We'll go ahead and refresh that again. Let that finish. So as soon as that completes, there's a JavaScript callback that gets called. And then here we are on our ASP.NET Core backend with our own sign-in method. And what we're doing is we're basically making the app potentially support multiple authentication providers. So Google may not be the only authentication mechanism. And so what we're doing is we're taking that JSON Web Token and we're going to invoke our own sign-in, because in the future there might be other sign-ins like, I guess it's Apple Store, maybe Facebook, maybe Microsoft, maybe our own. And so we are also using the Google libraries to decrypt the Google payload. And so they have the Google JSON Web Signature payload class. And then we'll go and run that. And so the payload, you can see we have all of our information. We have my email, we have my name, we have the issuer is accounts.google.com. So we have everything in that JSON Web Token. And then we actually have the JSON Web Token itself somewhere in here. I want to say, I don't remember where it's at. Anyway, we're going to go down. And so we're basically verifying that the email sent to us from the web app. So we have a request up here with the email address as well. Oh, there it is. There's the JSON Web Token from Google. And then we decrypt that JSON Web Token, and we're doing a little bit of a verification step to ensure that the email contained in the payload actually matches the email that was sent in the sign-in request to us. Okay. So then we do that, and then the way this is designed is we create a user. If one doesn't already exist in our database, there's a SQL database backing this application. Or if there's already an existing user by that Google Play ID, we look that up, and then we have our user. And then we are actually setting the HttpContext.User instance. So that way we can basically say the user is currently authenticated. And then we basically create our own JOT token that contains information we've set. And we can actually go look in the JOT factory class. And so basically we create a token handler, token descriptor. There's our audience, our issuer. We have a claims identity with the user ID, which is effectively the email address, and then the signing credentials, and we're using HMAC SHA-256 signature. And so we get that back, and then we basically return our own JOT token to the app. And so the app effectively has two JOT tokens. There's a Google Play or Google account JOT token, and then our app's JOT token. And so what we want to do is that's just the sign-in step. And so if we run the app, we are signed in. And so now I can navigate around the app and access some different screens. But now we need to make additional web API requests. Like in my alliance, we want to make a request to get the alliance details for me. And to do that, we have a me controller, which is authorized, because you shouldn't be able to really call these service endpoints if you're not authorized. But in here, because the ASP.NET Core Web API is sessionless and stateless, we don't have the concept of that HttpContext.User at this point in the code. So if we actually rerun this and we navigate around, we're in here, And if we go look at that class, so let's go watch window and let's go HTTP context. I may not even be able to get the HTTP context from here. Actually, how do we do that in the job factory? User controller. What was HTTP Context.User? Or okay, so we do have access to it. I feel like that. Why do I feel like that's not actually? Oh, .user. Sorry, it's not .current. So it's just HTTP Context.User. Interesting. So there actually is. So ASP.NET Core did actually persist our user. We set that. I thought we were going to have to do that because in the documentation, if you do your own sign-in, you have to set HTTP context user as well as the current thread principal user. And so I wonder if that actually has a value. So let's go look. So let's navigate back, go back here. So what if we do thread current principal is null? So we're not setting that. And I believe based on the documentation, we need to set that. So if we F1, or well, I guess we're gonna have to look it up. So let's go look up HTTP context user property. And we'll read the remarks. Provides programmatic access to the properties and methods of the iPrincipal interface. Because ASP.NET pages contain a default reference to system web, you can reference the members of HTTP context on ASP page. And oh, that's full framework. We want .NET Core. So we want .NET, let's say 8, I think is what we're targeting. There we go. Oh, it referred us back to .NET Framework 4.8.1. That's interesting because you're actually targeting .NET 8. So I actually wonder if we F1. There we go. ASP.NET Core 8.0. This is the documentation we want. No remarks on the user property. Nice. Awesome. Okay. So effectively, then we're going to have to do some research. So ASP.NET Core HTTP context user set plugin. So he's writing middleware. I think that's probably what we'll do, is end up writing some middleware as well, because we might need to handle this, but it seems like ASP.NET Core is persisting that automatically. So we are already setting it. So we've taken care of that piece. What's interesting is I would like to know if I want to know the life cycle around it, and that's ultimately what we're looking for. And I believe there's a article just here. And I want to say it's going to be under docs for ASP.NET Core Authentication. User properties, session. Let's start here. Encapsulates all information about an individual HTTP request and response. I wonder if HTTP context is static in context of it lives outside of an individual request, but then it has a request object for that request. Well, here we go. It has information about the incoming request, and it's initialized when an HTTP request is received by the server. It's not read-only. Well, that's HTTP request. So it is referring to the request property of the HTTP context. Is populated each time, is what it sounds like. Every time there's a request, it gets a new value. Request body. Yeah, we're not looking for any of this right now. So it's probably going to be under authentication somewhere. Integration option, environments, logging monitoring, routing, host, middleware. I don't know what AOT stands for. Tutorials. Let's just look it up. Authentication. You know, it's easier just to go through. Oh my goodness. ASP.NET Core. Authentication. There we go. This is the article I think I'm looking for. So for our authentication, we are using the built-in middleware, and we are using the NuGet package for the JWT bearer authentication. We have that set up. We're using the Microsoft Identity Model libraries to deal with the tokens and things of that nature. So pretty straightforward. Authentication is responsible for providing the claims principal for authorization to make permission decisions against. There are multiple authentication scheme approaches. Here we go. There are multiple authentication scheme approaches to select which authentication handler is responsible for generating the correct set of claims. Authentication scheme, the default authentication scheme discussed in the next two sections, and directly setting HTTP context user. There's only a single authentication scheme registered. It becomes the default scheme. If multiple schemes are registered, and the default scheme isn't specified, a scheme must be specified in the authorized attribute. Otherwise, the following error is thrown. That's understandable. Default scheme, auth scheme, authentication handler. An authentication handler is a type that implements the behavior of a scheme. We're not really doing that. Authentication. Authentication scheme's authenticate action is responsible for constructing the user's identity based on the request context, returns an authenticate result indicating whether a user was successfully authenticated, and if so, the user's identity in an authenticate ticket. See authenticate async. A cookie auth scheme, a JWT bearer scheme, deserializing, validating a JWT bearer token to construct user identities. This is basically what we're doing. I don't know if we're doing it the official way. Authorize with the specific scheme. Yes, maybe that's where we want to start, but let's go look on the left-hand side here. So we've got choose an identity solution. We've already done that. Configure identity. We're not using the ASP.NET identity model. Or are we? We're not storing anything in the ASP.NET identity model database schema. There's no tables in my system. We have our own user table. We're not using the ASP.NET identity stuff. So as far as I understand, I don't think we're using that aspect of the framework. Authorization. Really, authentication that we're kind of concerned about right now. To see what we're trying to confirm is why HttpContext.User already has a value when ASP.NET Core is stateless, and if that's something that's being provided by the ASP.NET Core framework that we're not aware about. And then that's going to help us determine what we need to do next, if anything, at this point, with our login page. We don't have cookie authentication enabled, as far as I know. Certificate authentication, external authentication. We're not using any official means of, we're not using any NuGet packages that plug into ASP.NET Identity. So like they have add Google. We're not doing that. We're using their JavaScript experience. The reason we're doing that is, and it looks like we could do it with the Google button, but we're using the official Google button. We're not doing that. Facebook, Twitter, Microsoft, other providers. They're all third-party systems. So this isn't referring to even just JWT authentication. Dots in development. Multi-factor. I guess let's start with, we do have an SPA. We're not doing any of this stuff. Yeah, this is all implementing ASP.NET Identity. We're not really doing that. So let's skip the identity section and just focus just on authentication. Choose an identity solution. Basic identity management. Disconnected scenarios. Decide where user data such as sign-ins are stored. So are we really actually needing to look under authorization? Simple authorization. So we do have authorized attribute there. That's good. We are using claims. Feel like just aren't in the right place. How about authentication samples? This is like the hard part about software development is all the research. Let's actually do. So authenticate JWT. There is a particular article I'm looking for. There's a blog. AWT bearer. So he has an authorization handler or maximum office number. It's kind of a custom thing. He's implementing a claims policy. Because the way this works is it is going to validate the JWT token during authorization on the server. And so maybe that's why it's baked in, because the authorization token is actually sent to ASP.NET Core. And so if we again go look at our program.cs, so we have authentication set, we have bearer authentication added as part of the middleware pipeline, and we have it set up to do the validation of the JWT token. So because we're doing bearer authentication and we're sending a JWT token that we previously generated, maybe when it's coming into the ASP.NET pipeline, it's automatically validating that. And then therefore, when we get into our me controller, we already have HttpContext.User set. So let's test that theory. Let's stop the debugger. Let's actually go to our user controller. Let's actually comment out this line of code that does actually set HttpContext.User, because you can see here, I'm just actually setting it to a new claims principle. I'm not actually really doing anything with that. It's probably left behind code from when I was originally doing some research. We're going to rerun this back end. We'll reload our front end. We probably could have just done a hot reload. Let's go ahead and reload our front end. So that actually already ran because it ran a Webpack build. Go ahead and run. Let's let that run to the end. Navigate away, navigate back, and now we're in My Alliance, and HttpContext.User does in fact, yeah. So I think it is actually being handled by the JWT middleware that we have enabled, because it is already plugging in our information. So effectively, there's nothing we need to do. So basically, we already have our claim. Here's our SID claim, and then here's our email. So what we could do is actually take that and say string email equals HttpContext.User. And we know at this point that we're already authorized because the controller requires authorization. So it's not even going to allow us entry into the action method if we're not authorized. It's going to return a 401 not authorized under that case. And so we can assume HTTP context has a value here. And so here we can access the claims, and we can actually, we're going to do claim where type is claim types SID. That's how we're storing that. And then we can basically say string equals claim value. And now we can access our user stuff. So we need to access our user in the database, basically. So we're going to go UDB user. And we don't have a context here, so we actually need to plug one in. So we don't have a user repository yet. We are using domain-driven design as the kind of overall architecture of the project. So we have a domain project, data project. We have a client project, which we'll get into later. We have the API backend project, and the actual repositories for our domain entities are in the data layer, because that's where they, in my opinion, it's one place where they belong. So you can see we have all of our data access here, and we have our Alliance DB repository. We just don't have one for the user, but we do have a DB context. So we are going to inject in. We do actually have our Alliance repository, actually. So we're going to cheat because, as a matter of fact, what I did on that is it does have a context. So we do have a context, actually. And we're going to access the user table. And we're going to say single or default where user, I believe it's Google Play ID equals email. All right, I'm going to say if user is null, then we basically have a problem. We'll come back to that later. So for now, we're going to do not implemented exception. But if we do have a user, then we can come here and we can do some stuff. All right. And so effectively what we wanted to do was we're basically getting the user's alliance that they are managing. So we're going to basically say alliance repository, we're going to do alliance. We're going to do find by, and actually we need to do find by user. Manage user. We're going to create this very specifically, and we're going to pass in the user UID. Create that method. Okay, so in our repo, we're going to basically say in the design of the repo is we have a query property that exposes iQueryable, and that defines the query expression that accesses the data. So you can see here we're including the alliance, and then we do have, should actually have manager ID is effectively the user ID. This actually needs to be an integer, as a matter of fact. I'll get into that later. The database design has both ints and GUIDs. This will actually be user ID. We're going to say DB alliance entity query, single or default, where the manager ID equal to the user ID. We're going to actually say manager ID. We're going to rename this to find by manager ID. And then we're going to say entities return null because we can't find it. Then we're going to return map the alliance entity or domain entity. Return that. We already have some of this code built out. So the app is somewhat functional. 2degree is very basic functionality. So now we can come back here and repair this to say find by manager ID. So it'll actually be user ID. And then now we can say if alliance is null, then return not found. Otherwise, we'll return OK. We'll actually go ahead and just return the alliance object itself. Okay. We're going to rebuild and apply. Make sure everything compiles. Great. We'll go ahead and set a breakpoint. We'll step through this. There's our claim. There's our email. There's our user. There's our alliance. There's all of our domain data. Nice. And we're going to get our alliance returned back to us. Nice. Now, let's make sure that came across the wire as we're expecting, just for kicks and giggles. We know it did. There it is. Let's check the endpoint. Yep, API/me/alliance. You can check the headers. Should be an authorized header. There's our authorized header. Nice. And then there's our response with our alliance. Nice. That was fun. And so the idea with this particular screen is that if I am authenticated and I do not currently have an alliance that I am managing, I would be presented with this screen to create one. But if I have an alliance that I'm managing, we would not present them with this screen. We will present them with their alliance that they manage and allow them to manage that alliance. So anyway, so turns out, I guess what we were trying to confirm in the first place was how to take that JOT token. And the video was originally going to be kind of like, how do we read and deconstruct the JOT token? And then how do we populate HttpContext.User and Thread.CurrentPrincple.User and make sure that that's available as part of this stateless, sessionless ASP.NET Core backend. And turns out that it's actually doing all of that for us automatically, which is actually really cool. So in this JOT factory, we did have a read token method that I had written because it's pretty straightforward using Microsoft's identity APIs. You just create a JOT security token handler class, and then that has a read JOT token method, and you basically pass it your base64 encoded token string, and it returns back to a JWT security token, and on that token you have access to all your stuff, including the claims and everything. And so we were going to use that to deconstruct the JOT token and bring that in and do all that other work. But the cool thing about this video is I wanted to do just kind of a Friday night coding problem solving mindset type video. And so you guys are getting to go along for the mental ride with me. And my mind is a little bit of chaos, but doing the research involved, because not having the answer and kind of going through that process so you can see, like, how are we actually going to have a problem we don't yet know how to solve? And then how are we going to solve it and going through that entire process was kind of the idea with the video. And so let me know in the comments below if you guys like this type of video. They're a little bit longer. I think now we're at 30 minutes, but it was kind of a fun little problem to solve and kind of a fun little thing to actually have a fun little app to work with. And if you like these, we'll do more of them. If you don't, I will do something different. So definitely remember to like and subscribe the video. Let me know if you liked it and add some comments below. I will more than happily chat with you.